Hello everyone, we are going to start with M2, M1, Unit 2. Special thanks to Dr. Mohammed Ahmed sir. Sir, you really are an ideal teacher. So the name of the chapter is Calculus of One Variable. So we are going to start with Rolle's theorem. So Rolle's theorem is an important question. It has been asked many times. Okay, so let's start with it. So let f of x be a function defined in a comma b, okay, such that f of x is a continuous on closed interval a comma b, okay, open brackets a comma b, okay. Next point, if f of x is differentiable on open interval a comma b, then f of a is equal to f of b. Then there exists at least one variable c belongs to a comma b such that f dash of c is equal to 0. So number one thing is f of x be a function defined in a comma b. Okay, closed interval a comma b. So number one thing is f of x should be continuous. F of x should be continuous. Where it should be continuous between closed interval a comma b. Okay. Next thing, it should be differentiable. Where should it be differentiable? In open interval a comma b. Okay. Then f of a should be equal to f of b. Okay. Then there will exist at least one variable c belongs to a comma b such that f dash of c is equal to 0. If all these conditions are met, f of x is continuous at closed interval a comma b, differentiable at open interval a comma b, and f of a is equal to f of b, then f dash of c is equal to 0. Okay, this is Rolle's theorem. Now proof. This is a very important question. Practice it. Okay, first understand it. Make sure that you are having a pen and a paper. Write it again and again. Okay, use the power of divide and rule. Okay, you have to divide the problem into parts and understand it one by one. Okay, and rule. Okay, so given f of x is continuous on closed interval a comma b. F has both maximum and minimum value. Let f of capital M be a maximum and f of small m be a minimum value of f on closed interval a comma b. Okay. Now take first case. In the first case, let f of capital M is equal to f of small m. Okay. If f of capital M is equal to f of small m, then f of x is same for all x belongs to closed interval a comma b. f is f of x is constant. F dash of x is equal to 0. Therefore, x will belong to a comma open interval a comma b. C can be anything in a comma b such that f dash of c is equal to 0. This was the case 1. So what have we understood? If in case 1, if f of m, let f of m capital M is equal to f of small m. Okay, f of x is same for all x belongs to closed interval a comma b. F of x is constant. F dash of x is equal to 0 between open interval a x belongs to a comma b. Then c can be anything between a closed interval a comma b such that f dash of c is equal to 0. Okay. Now, case 2. Let f of capital M not equal to f of small m. In first case, it was f of capital M is equal to f of small m. In second case, we are taking it as f of capital M is not equal to f of small m. Either for f of m, capital M, or f of small m is not equal to f of a is not f of a is equal to f of b. Okay, either for f of capital M or small m is not equal to f of a is equal to f of, let f of capital M is not equal to f of a is equal to f of b. Then a will not be equal to m, not be equal to b. But m is a closed interval a comma b. M is in closed interval a comma b. Note that the end prints m belongs to a comma b. Okay, open interval a comma b. Since f of m is maximum value, okay, f of capital M is the maximum value, f of capital M will definitely be more than f of x. Therefore, f of x belongs to open interval a comma b. Sorry, close interval a comma b. Okay. So f of, so open interval a comma b, okay, is similar to close interval a comma b. So f of capital M is more than or equal to f of x. Therefore, x belongs to open interval a comma b. So f of capital M is local maximum. What is it? F of capital M is the local maximum. Okay. Also given f of x is differentiable on open interval a comma b. Local extrema theorem says that f dash of m is equal to f dash of capital M is equal to 0. We are taking c is equal to capital M. So we showed c belongs to open interval a comma b such that f dash of c is equal to 0. So this is a geometrical representation of Roller's theorem. If f of x is continuous on open interval a comma b, sorry, close interval a comma b, and f of x is smooth, differentiable, smooth, it means differentiable in open interval a comma b, and f of a is equal to f of b, then there exists at least one c belongs to open interval a comma b such that the tangent drawn at f of c will be parallel to x-axis. As you can see, there is a tangent drawn to this curve, okay, and this tangent, it is parallel to x-axis. Okay, this is the geometrical representation of Roller's theorem. Understood? Now practice this question 5 times because it is very important. As you can see, okay, it is very much important. Practice it 5 times. You have one shot at this. Okay. Next is Lagrange's mean value theorem. Okay. This is also the second most important question. Okay. Let f of x be a function defined in a comma b. Okay. Closed interval a comma b such that f of x is continuous on closed interval a comma b. Okay, f of x should be continuous on closed interval a comma b, differentiable on open interval a comma b. Okay, it is just like Euler's theorem. Continuous on closed interval a comma b, differentiable at open interval a comma b. These two are same from Roller's theorem. Okay. Now, then there exists at least one value of C belongs to A comma B such that f dash of C is equal to f of B minus f of A by B minus A. Understood? This is the formula. If these two conditions are met, then we can use this formula to find f dash of C. Now for the proof. Okay, first of all, remember this. Define g of x is equal to f of x plus ax. That is the equation 1. In closed interval a is to be determined such a way that g of a is equal to g of b. Okay, g of a is equal to g of b. G of a is equal to g of b. Just substitute instead of this x, substitute a. So what will it be instead of this x? If you are substituting a, then f of a plus a small a. Okay. Similarly, instead of g of b, substitute b. Okay. So what will it be? F of b plus ab. Okay. A small b. So you will get this equation: f of a plus capital A small a is equal to f of b plus capital A small b. Now, take this AB to that side, okay, and take f of A to this side, to your right hand side. Then take capital A as common. Then what will you get? A bracket A minus B is equal to f of B minus f of A. If you send this A minus B to that side, okay, take minus, okay, if you take A minus B to that side, you will get it as A is equal to f of b minus f of a by a minus b. This will be your equation number 2. Now, we got the value of a. Since f of a is not continuous on closed interval a comma b, g of x is also not is continuous on closed interval a comma b. Since f of x is continuous on closed interval a comma b, g of x is also continuous on closed interval a comma b. Since f of x is also differentiable at open interval a comma b, g of x is also differentiable on open interval a comma b. Substituting the values of a in 1, okay, we will get g of a is equal to g of b. So G is satisfying all the conditions of Roller's theorem, the theorem we have learned, okay, just now. Okay, it is satisfying all the conditions of Roller's theorem. So then there exists C belongs to A comma B, okay, open interval A comma B such that G dash of C is equal to A. Now what is G dash of C? G dash of C will be. So differentiate this equation, equation 1. If you differentiate this equation, what will you get? F dash of x plus a. Okay, if you differentiate it, you will get it as f dash of x plus a. What is a? We can substitute from your equation number 2. Okay, you can substitute from your equation number 2. The value of a is nothing but f of b minus f of a by a minus b. So f dash, send this a to that side. Okay, f dash of c is equal to minus a. What is a? F of b minus f of a by a minus b. Okay, if you multiply this sign to the denominator, you will get it as f dash of c is equal to this a minus b will change to, after multiplying the negative sign, b minus a. So f of b minus f of a by b minus a will be a final equation. Okay, so there are simple steps. Number 1, you have to remember g of x is equal to f of x plus ax. Number 2, g of a is equal to g of b. Okay, then substitute and find a. Then, since it follows Roller's theorem, okay, It is continuous and differentiable, continuous at closed interval a comma b, differentiable at open interval a comma b. Okay, it can apply. We can apply Euler's theorem. What was Euler's theorem? F dash of c is equal to 0. So here we are using g dash of c. What is g dash of c? Differentiate the first equation. If we differentiate it, we will get g dash of c. So we got this g dash of c. I hope you have understood. G of c is equal to, what is it equal to? F of c plus ax. If you differentiate this, what will you get? G dash of c differentiation. Okay, sorry. Instead of this x, you have to write c. Okay, G dash of c is equal to f dash of c. Differentiation of f of c will be f dash of c plus differentiation of ac will be a. Okay, then you can substitute and you will get the final answer. Practice this question at least 5 times right now. Okay, with seeing or without seeing. Okay, now what is the geometrical representation of this? If f of x is continuous on closed interval a comma b and f of x is smooth differentiable on, or smooth means differentiable on open interval a comma b, then there exists at least one c belongs to a comma b such that the tangent drawn at f of c is parallel to the line joining a and f of a and f of b. So now this is your, in this graph, as you can see, this is your f of a, this is your f of b. If I join these two lines, the dotted line, okay, this is the graph. Okay, on this graph there is one point c belongs to a comma, okay, open interval a comma b. Open interval means it will start from here and end at here. Close, okay. There's one point. Okay, and this point, at this point, if you draw a tangent, it will be parallel to, if you join these 2 points, f of a and f of b, it will be parallel to this. Understood? Similarly, for this one, it is 1 point, it is 2 points, there can be many points, but these all points, they at least one, but they can be many. Okay, it's telling at least 1 point, but they can be many points. Okay, and these type of question, write a geometrical, okay, interpretation of Euler's theorem or geometrical representation of this theorem, they can ask you in SAQ. Okay, in SAQ it can be asked, and it is very easy. Understood? Next, Cauchy's mean value theorem. Cauchy's mean value theorem is also very easy. Okay, and it is also very important. Okay, as you can see over here. Let f of x and g of x be two functions defined at closed interval a comma b. Then here you are having two functions, f of x and g of x. What are the conditions? F of x and g of x are continuous in closed interval a comma b. Number one is continuous. Number two is f of x and g of x are differentiable at open interval a comma b. Okay. Now for the third condition. The third condition is g of x should not be equal to g of x dash, g dash of x. It means the differentiation of g of x is g dash of x. G dash of x should not be equal to 0. Okay, x will be between, x belongs to open interval a comma b. G dash of x must not be equal to 0. Why? Because g dash of x is in the denominator. If denominator becomes 0, it will become undefined because 1 by 0 is undefined. Okay, these are the three conditions. Number one, f of x and g of x should be continuous at closed interval a comma b. Second, remember these brackets, this is closed interval. These type of brackets are used, it's closed interval. And these brackets are used, it means open interval. These are the basic concepts. Okay, these smooth curved brackets are used. Okay, also known as parenthesis. Okay, it is used for, okay, open interval. Okay, now for the proof, you have to remember the formula. It will be very easy and helpful. Just like we have learned in Lagrange's theorem, in this theorem you have to remember this equation. What is the proof? Define h of x is equal to f of x plus kg of x. This equation is your equation number 1. Okay, f of x plus k g of x, where k is to be determined in such a way that h of a is equal to h of b. Okay, it is also following the same as Lagrange's mean value theorem. Now substitute, instead of x you have to substitute a. So instead of this x, if you substitute a, f of a plus k into g of a will be equal to f of b. Instead of h of x, you have to write b. H of b is equal to f of b plus k into g of b. Got this equation? Now send this g of k into g of b to that side and send this f of a to right hand side. Then take k as common. If you take k as common, what will be left? G of a minus g of b. Send this g of a minus g of b to right hand side. Here it is in multiplication. So if you send it to right hand side, it will go to division, right? Now, if you k is equal to f of b minus f of a by, now we are taking minus as common. Okay, we are taking minus as common. So what will we get? G of b minus g of a, where g of b minus g of a is not equal to 0. Why is it not equal to 0? Because it is in denominator. Now, this also follows Rolle's theorem, because if you learn Lagrange's mean value theorem, it is very similar. Rolle's theorem is okay, it is very similar. Okay, it will be very easy for you, don't worry. And it's very important, very easy. If you are perfect in one theorem, you can do the second and third theorem easily. Now f of x and g of x are continuous on closed interval a comma b. Then h of x is also continuous on closed interval a comma b. Since f of x and g of x are differentiable on open interval a comma b, h of x is differentiable on open interval a comma b. Okay. Now h of a is equal to h of b. Now this satisfies all the conditions of none other than our Rolle's theorem. It is satisfying all the conditions of Rolle's theorem. So now what can we do? Therefore, there exists C belongs to a comma b. Okay, open interval a comma b such that h dash of c is equal to 0. Now find h dash of c. What will be h dash of c? This is your h of x is equal to f of x plus k into g of x. What will be the differentiation of this equation? H dash of x, differentiation of h dash of x is equal to, this is f of x, the differentiation of f of x will be f dash of x plus k is a constant and it is in multiplication, so it will remain same. What will be the differentiation of g of x? Right, it will be g dash of x. Okay, now substitute. Okay, f dash of x plus k into g dash of x is equal to 0. Now send this f of x, f dash. So this here we are writing h dash of c is equal to 0 because according to Rolle's theorem, f dash of c is equal to 0. So here we are using h dash of c. So h dash of c is equal to 0. Okay, so f dash of c plus k into g dash of c is equal to 0. Send this f dash of c to that side. Then send this g dash of c below. So it will become minus f dash of c by g dash of c. Okay. Now what is f dash of c from equation 2? Okay. F dash of c by g dash of c. We can write k. What is k? We have just now found out the value of k, right? What was the value of k? K was nothing but this f of b minus f of a by minus of g of b minus g of a. Understood? F of b minus f of a by g of b minus g of a. Now negative sign, this negative signs, we had one negative sign over here and one negative sign over here. These two negative signs get cancelled and we'll get the final equation as this. F dash of c by g dash of c is equal to f of b minus f of a. Okay, these three theorems, okay, and the geometrical representations are extremely important. You have to make sure these are the most easiest 100% guarantee important question, and definitely it will help you in exam. Okay, so don't forget to practice it. Now Euler's theorem, okay, it's geometrical representation. Lagrange's theorem, it's geometrical representation. Cauchy's mean value theorem, and it's then you have to practice this. They all are interrelated. Don't get confused, because practice make you perfect. What is your memory? You have memory, right? How can you make it a permanent memory? Only by practicing it again and again. If you practice again and again, it will come into a permanent memory. Nothing is easy until it's done. Okay, it seems impossible until the time you think it is. Got it? So it is possible. So if you do this, you can easily score up to 15 marks. Got it? Now, Taylor's series. If f of x possesses derivatives of all orders, okay, then the Taylor series is given by f of x plus h is equal to f of x plus h into f dash of x plus h square by 2 factorial into f double dash of x plus h power 3 by h cube by 3 factorial into f triple dash of x till infinity. Okay, this is your Taylor series. Taylor series is important for 2 marks. Taylor series is very easy. It is really important for 2 marks. Okay. Before going to 2 marks, you see the plan. Today, practice this all questions what you have learned today 5 times. If you have any doubts, feel free to ask. Okay. Today. Then tomorrow again, as soon as you wake up. Okay. Just practice again 2 times, and this time try one time you can just see, revise and practice, and second time just try to do it without seeing. Okay, then if you can do it without seeing and you think you are perfect, then you can practice it once again without seeing, just one day before the exam. Okay, there are 2 types of revision. One, you have to write test and examine yourself whether you are perfect or not. This will give you confidence to when you appear in exam. Okay, so practice it without seeing. It will really help you in exam because you have already done it in the past without seeing. Okay, so now Taylor's series. So this is your Taylor's series, and it's very easy. As you can see, there is a rhythm. Okay, what is it? F dash of x plus, okay, f dash of x plus h into f dash f of x plus h into f dash of x plus h square by 2 factorial into f double dash of x. Right? I think we are following this series over here. This is your Taylor series, I think. Okay. Now note, put x is equal to a and h is equal to x minus a. Then what will it become? Instead of x you are putting a, instead of h you are putting x minus a. So instead of this x, put a. We have put a over here. Instead of this h, put x minus a. Can we put like that? Yes, definitely we can put like that. X minus a. Okay. Now, instead of this x, we are going to write a f of x plus. Instead of this h, we are going to write x minus a. Then instead of f dash of x, we are going to write f dash of a. Then instead of h square, we are going to write x minus a whole square. 2 factorial will remain same. F dash of x, instead of this x, we are again going to write a. H cube. What is h? H is nothing but x minus a. So instead of this x, h, we are going to write x minus a whole cube by 3 factorial. Okay. Then f triple dash of, instead of this x, we are going to write a, because x is equal to a till infinity. This is the second equation, and this is more important. And if you know this equation, if you have learned this equation, this series, and if you remember that x is equal to a and h is equal to x minus h, you can easily derive it, right? Just try to practice 2 to 3 times now itself and you will get it. Okay, you can pause it and practice 2 to 3 times. Hence, here 2 is known as Taylor's series in powers of x minus a, or Taylor's series in expansion about x is equal to a. So if it tells you, okay, Taylor series expansion about x is equal to a, or in powers of x minus a, you have to use the second equation. Understood? And it is very much important for this 2 marks. It's 3 marks. You have to just remember these two equations. Just practice these two equations without seeing for 10 times. Okay, at the back of your notebook. Just practice it 10 times. It's no big deal. It will take hardly 5 minutes. But you will be perfect. Next is Maclaurin series. Yes, Maclaurin series, you have to put x is equal a is equal to 0 in 2. This equation 2 we got just derived. Okay, we are going to derive one more equation, that will be your Maclaurin series. Okay, instead of a, if we put 0, then f of 0 plus x into f of dash of 0 plus x square by root 2 by 2 factorial into f double dash of 0. Okay, what are we doing? We are putting in this equation 2, this equation 2, we are going to, this equation 2 we have, right? In this equation 2, we are going to put a is equal to 0. So this will also become 0. This will also become 0. Sorry. This will also become 0. This will also become 0. Okay. A is equal to 0. A is equal to 0. So what will be left? F of x plus, sorry, f of 0 plus f of x into f dash of x plus x square by 2 factorial into f double dash of 0 plus x cube by 3 factorial into f triple dash of 0 plus till infinity, which is known as Maclaurin series. Taylor series is about x is equal to 0 is Maclaurin series. Okay, Taylor series about x equal to 0 is Maclaurin series. This is also for 2 marks, that is your SAQ. Okay, we are going to do the easy stuff, okay, and the important stuff, so that we can score more marks. Okay, we are going to apply the 80-20 principle. We are going to work less, but we are going to work smart. Okay, so that we can gain more marks in less amount of time and less amount of efforts. Okay, if you have, you can take it as next is Rollo's theorem. If you are thinking that I am going slow, you can double X the video, or if you think that I am going too fast, you can go you can decrease the speed by into minus 0.2 or 0.5 as per your convenience. Okay. Now f of x is defined as f of closed interval a comma b, where okay then f of x is continuous on closed interval a comma b. This was the Roller's theorem, first point. Next point, f of x is differentiable. What do you mean by differentiable? It should not have breaks in between. In this graph, between point f of a and f of b, it should not have any amount of breaks. Okay, it should be complete smooth. If it is having breaks in between, okay, then it will not be differentiable. Got it? When is it differentiable? If it does not have any breaks. Then f of a is equal to f of b. Then, therefore, c belongs to open interval a comma b. Then f dash of c is equal to 0. Then Lagrange's f of x is differentiable on closed interval a comma b. Then f dash of x is continuous on closed interval a comma b. Then f of x is differentiable on open interval a comma b. Then, therefore, c belongs to open interval a comma b. Then f dash of c is equal to f of b minus f of a by b minus a. Then Cauchy's and rule test, sorry, Cauchy's mean value theorem. What is Cauchy's mean value theorem? It is very similar. F of x and g of x, that two equations given, differentiable on open interval, sorry, closed interval a comma b. F of x and g of x are continuous on closed interval a comma b. Okay, f of x and g of x are differentiable on open interval a comma b. G of x is not equal to 0 because denominator must not be equal to 0, or else it will become infinity or undefined. And x belongs to open interval a comma b. Then c belongs to open interval a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. There are problems also on these three theorems. Okay, inshallah we'll do it in future. Next is Taylor series. Just remember this equation or this series. Okay, then substitute x is equal to a and h is equal to x minus a. Okay, instead of h we have to substitute x minus a, and instead of x we have to substitute x is equal to a. H is equal to, in this h is equal to x minus a. If you substitute this, you will get this series. Then in this series, if you substitute a is equal to 0, a is equal to what? 0. Then you will get this series. Okay. So what is our plan? We have to practice these questions, these theorems 5 times today, 2 times tomorrow, and 1 time 1 day before exam. Okay. Consistency is the power. Okay. A weak and soft droplet of water, okay, can destroy a stone, can make cracks into a stone, okay, into a rock which is hard. Okay, why? Because it is consistently falling on the same spot again and again, again and again, again and again. That is why it is able to crack, even though the droplet is weak, but the droplet is consistent. Therefore, it was able to break that rock. So you also have to be consistent. You have to get out of a comfort zone. You have to give a try, and definitely you will succeed because you have to. You're giving your 100%. What matters is Are you giving your 100% or not? Are you giving your 100% as per your capabilities? If you are capable to bring that much, you have to give your 100%. Okay, that is life. Okay, ये वक्त भी गुजर जाएगा, ये वक्त भी गुजर जाएगा, मैं यहाँ आया हूँ यहाँ रहने के लिए नहीं और आगे जाने के लिए. Okay, so keep believing in yourself, work hard, achieve big. If you have any doubts, feel free to ask.